All right, let's go ahead and get started. This is going to be a video on the sum or difference of angles with trig functions. Now, as always, I'm going to skip over the warm-up, but what is important from the warm-up is knowing which or how to find your sine, cosine, tangent of various angle measurements that we have worked with before, right? Whether that be from 0 or pi over 6, pi over 4, pi over 3, pi over 2, all the way around the circle, those normal angle measurements, okay? Those are very important. Another thing that is important for us is sometimes you aren't able to find something like 5 pi over 12. So we need to kind of change how it looks. So in order to do that, we need to, well, what's lucky for us, or not, I shouldn't say lucky, but we basically are trying to find the common denominator for pi over 6, pi over 4, pi over 3, pi over 2, and that's going to be 12. So I'm going to first rewrite each of these so that I have this handy. Pi over 6 is the same thing as 2 pi over 12. Pi over 4 is the same thing as 3 pi over 12. Pi over 3 is the same thing as 4 pi over 12. And pi over 2 is the same thing as 6 pi over 12. Now, there's nothing crazy about the sum and difference of angles for my trig functions, for these identities. You kind of just take what's given to you here, and you kind of just substitute in the values, right? And so, for example, sine of a plus b is going to be sine of a cosine of b, right? The sine of a multiplied by cosine of b plus cosine a sine b. Notice that the signs here are different. I'm sorry, they are the same. They will match plus or minus, plus or minus. But when it comes to cosine, it's going to differ. This is plus or minus, this is minus plus, meaning if you add, it will be matched with the subtraction. If you subtract, it will be matched with the addition. Also, it's cosine, cosine, then sine, sine. For sine, it was sine, cosine, cosine, sine. So just small variations, be careful. I think these are not too bad, though. Tangent is really the one that's kind of crazy. But these identities are given to you, so you don't really have to memorize them. You should be able to just use them straight out the box. So let's go ahead and take an example here. We have sine of pi over 3 plus pi over 4. If we did this, like quote unquote, when we combine them, we'll get 4 pi over 3 plus 3 pi over 4. We get 7 pi over, 12. We get sine of 7 pi over 12. We can't do that, right? And from our warm-up, we have found that sine of pi over 6 plus pi over 3 is not the same as sine of pi over 6 plus sine of pi over 3. So we do need these identities, these sum of angle identities. All I'm going to do is take a look at what it is, what the identity is from what's given to me. So sine of a, so sine of pi over 3, multiplied by cosine of b, cosine of pi over 4. Now be careful, the sum and difference for sine, the addition slash subtraction will match. So this is addition, so plus cosine of pi over 3 multiplied by the sine of my second angle, pi over 4. Right? At this point, this is where we really need to know your evaluation, your sine, cosine, tangent of all the different angle measurements. Again, if you're using your chart, that's perfectly fine. You also need to keep in mind exactly what quadrant we're in. So both pi over 3 and pi over 4, they're both in quadrant 1. So they're all going to be positive here. Sine of pi over 3 will be root 3 over 2. Cosine of pi over 4 will be root 2 over 2. Plus cosine of pi over 3 is 1/2. Sine of pi over 4 is root 2 over 2. Right? So it might be a good idea just to put parentheses around just so you can see, okay, this became this, this became this, this became this, this became this. So I have root 6 over 4 plus root 2 over 4. That's equal to root 6 plus root 2 all over 4. We can't actually simplify this further. We'll just leave it as such. At any point, if you need to pause, please pause. I'm just going to keep on rolling here. Sine of 3 pi over 4, this is in quadrant 2. Pi over 3 is in quadrant 1. Just kind of as a mental note for me, as I'm going to be using my my sum of angles identity here. So sine of the first angle, so sine of 3 pi over 4, cosine of pi over 3. Be careful, this is not negative pi over 3, it's just pi over 3. The sign here will stay the same, right? This is staying the same. So minus will be minus cosine of my first angle, sine of my second, pi over 3. Sine of 3 pi over 4, sine is positive in the second quadrant, so this is still root 2 over 2. Cosine of pi over 3, this will be 1/2. Minus cosine is negative in the second quadrant, so this is negative root 2 over 2. Sine of pi over 3 is root 3 over 2. Simplify, so I have root 2 over 4 minus a negative root 6 over 4. So this is going to be a root 2 plus root 6 all over 4. So it's actually the same value as earlier. All right. Cool. Let's keep it moving. So we did 2 examples of sine. Let's take a look at cosine here. Cosine will be slightly different. But again, just note for yourself what quadrant we're in. This is quadrant 3. This is quadrant 1. Okay, so cosine is a little bit different. The sign is going to change, right? So if it's addition, it will become subtraction. Subtraction will be addition. Not only so, but the order of our trig is different. Earlier, it was sine, cosine, cosine, sine. Now it's cosine, cosine, sine, sine. So let's rewrite this. Cosine of 4 pi over 3 multiplied by cosine of pi over 6. It was addition. Now it's subtraction. Sine of 4 pi over 3. Sine of pi over 6. Again, cosine is negative in the third quadrant, and cosine is so negative 1/2 at 4 pi over 3. Cosine of pi over 6, that's root 3 over 2. Sine of 4 pi over 3 is also negative, right? Tangent is the only trig function that is positive in quadrant 3. So sine of 4 pi over 3, this is root 3 over 2. Negative root 3 over 2, sorry, let me rewrite that. Negative root 3 over 2. Sine of pi over 6 is 1/2. So for those of you that see, these are actually the same numbers. One is positive, or both are negative. So this will be actually sum up to 0. But I'll write out all that so you can kind of see more clearly. This is root 3 over 2, root 4, negative, minus a negative root 3 over 4. Right? Plus plus, this is equal to 0. Now, this is the time when we really had to think about, okay, well, what the heck is 7 pi over 12? I don't know how to do this normally, right? So I need to rewrite this 7 pi over 12. 7 pi over 12, that's equal to, well, luckily for us, I can rewrite this as 3 pi over 12 plus 4 pi over 12. And the reason I want to do this is because this does simplify to pi over 4 plus pi over 3. These are values that I can actually work with. I know how to find the cosine and sine and tangent of pi over 4. I also know pi over 3 as well. So again, follow along with whatever is the identity here. I'm going to do cosine of the first angle, so cosine of pi over 4. Oh, I'm sorry, I should write down what quadrant these are in. These are both in quadrant 1. Pi over 4 multiplied by cosine of pi over 3. This was addition, so now I have subtract sine of pi over 4, sine of pi over 3. Evaluate each one. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 3, parentheses, is 1/2 minus root 2 over 2 times root 3 over 2. So I have root 2 over 4 minus root 6 over 4, and we can combine these, root 2 minus root 6 over 4. And just to kind of like sort of double check, we know that 7 pi over 12, well, that's slightly more than pi or 6 pi over 12, which is pi over 2, right? So this is in the second quadrant. So this is second quadrant. This is Q2. Cosine is negative in the second quadrant, which this does show, right? Root 2 minus root 6, that's a negative number, right? So this is negative, so this value does make sense. All right, let's go to the next problem where we have our tangent. Excellent. We do have 5 pi over 12. It might be a good idea just to take a look at this table and see, can I get 5 pi by adding or subtracting or something, right? The only way to get 5 pi would be 2 pi plus 3 pi. So I'm going to rewrite this 5 pi over 12 as 2 pi over 12 plus 3 pi over 12, which I know is pi over 6 plus pi over 4. So I can rewrite my tan of 5 pi over 12 as tan of pi over 6 plus pi over 4. Let me rewrite that. That's very ugly. Now I'm going to do is I'm going to, one more thing is I'm going to go ahead and make sure I know which quadrant I'm working with for each of these. And in fact, 5 pi over 12, this is actually also in quadrant 1. And I know that because 6 pi over 12 is half, right? That's 6 pi over 12 is here. So this is quadrant 1 because it's slightly less than that. Following what I have here, tangent of A is pi over 6. Now here you have to be careful. The numerator, the sign matches, plus or minus, plus or minus. The denominator is minus plus, so it's the opposite. So tan of pi over 6 plus the tangent of pi over 4. This whole thing is over 1 minus tan pi over 6 multiplied by tan of pi over 4. So be careful here. We do have addition in the numerator, multiplication in the denominator between my tans. Tan of pi over 6, that is, what is that? That is 1 over root 3. Tan of pi over 4 is 1. 1 minus, now the good news is we already did this calculation, so 1 over root 3 multiplied by 1. And we're not going to do crazy simplifying here. We're just going to leave this like so. We could like try to rationalize each of the fractions and make it a little bit cleaner, but it's okay. It's not a big deal. Here, there's nothing we need to change. 2 pi over 3. This is in quadrant 2. 5 pi over 6 is also in quadrant 2. Okay, just kind of remind myself. So that means every tangent is going to be negative. It's going to be a negative value. Again, following along with what I have here, tan of 2 pi over 3. This top, the numerator, the sign's going to match. Tan of 5 pi over 6. All over. Denominator, it will not match. So 1 plus tan of 2 pi over 3. Tan of 5 pi over 6. Okay, so here I have tan of 2 pi over 3. That's going to be root 3, negative root 3, minus negative 1 over root 3, all over 1 plus negative root 3 multiplied by negative 1 over root 3. So the denominator is kind of nice because this is multiplied. The root 3's will cancel out. The numerator would just be negative root 3 plus 1 over root 3 all over. This becomes 1. So 1 plus 1 is 2. So here we are going to go ahead and, again, we need to separate my 7 pi over 12. Luckily for us, we did take a look at 7 pi over 12 earlier. We have found 7 pi over 12 is the same thing as 3 pi over 12 plus 4 pi over 12. So cosine, now again, just for our own sake, right, this is in quadrant 2, but I'm going to rewrite this as cosine of pi over 4 plus pi over 3. This is quadrant 1, this is quadrant 1. And so following along with what cosine is, the sum of angles or difference of angles, this is cosine of pi over 4, cosine of pi over 3. This was addition. Now we have subtraction. Sine of pi over 4, sine of pi over 3. Cosine of pi over 4, this is root 2 over 2. Cosine of pi over 3, this is 1/2. Sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. So I have root 2 over 4 minus root 6 over 4, which is, I can simplify this to one thing, and that's it. Once again, cosine in quadrant 2 is negative. This is, again, a negative number, so this does make sense. We have another cosine problem, and in subtraction, we are going to, I don't have to do anything crazy here. This is not in any quadrant. This is a quadrantial, right? This guy is right here. This guy is in the third. This is quadrant 3. All right, so cosine of 5 pi over 4 times cosine of 3 pi over 2. This was minus, so now I have addition. Sine of 5 pi over 4, sine of 3 pi over 2. Now, it is nice to know your quadrantals because on the y-axis, cosine is 0. Right, you can think about it as if I was trying to create a triangle, there's no base. There's no base, right? So therefore, it has to equal to 0. So this is 0, meaning this whole side is 0. Okay, so I don't even need to write that out. But again, just for the sake of those that maybe don't see that off the bat, quadrant 3 is negative, so negative root 2 over 2 multiplied by 0, plus this is also negative root 2 over 2, sine this is negative 1. Right? Again, just like I said before here, this is going to cancel out because it's just 0. I am left with just positive root 2 over 2. Just a couple more problems here. This one's a little bit trickier, right? Because pi over 12, we can't add to pi over 12. I guess we could try to do like negative angles and stuff like that, but again, like why try to go crazy and stuff? I mean, I guess you could try to do that. But either way, your job is to try and figure out which one has a difference of 1, right? So in this case, we can see that 4 pi and 3 pi are the ones that would work best for us. So pi over 12 is the same as 4 pi over 12 minus 3 pi over 12, right? So I can rewrite my sine. I'm going to rewrite my sine of pi over 12. This is the same thing as pi over 3 minus pi over 4. And again, just for our own sake to kind of keep track, this is in quadrant 1. This is in quadrant 1. This is also quadrant 1, right? So we expect the number to be a positive value. Again, we're not actually calculating anything. It's just a general self-check. So this is sine. I'm going to look at just the sine one. So sine of the first angle, pi over 3, multiply cosine of the second, pi over 4. The sine will match, minus and minus. And then I switch my trig function. So cosine of the first angle, pi over 3, sine of the second angle, pi over 4. Sine of pi over 3, this is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Minus cosine of pi over 3 is 1/2. Sine of pi over 4 is root 2 over 2. This is root 6 over 4 minus root 2 over 4. Therefore, root 6 minus root 2 all over 4. And again, this is a positive number. Root 6 is bigger than root 2. Lastly, 5 pi over 12. We did do this earlier. This is what, pi over 2 and pi over 3. Or, I'm sorry, 2 pi over 12 plus 3 pi over, I don't know what I was saying. 2 pi over 12 plus 5 pi over 12, sorry. So then I can rewrite this as tan of pi over 6 plus pi over 4. Again, this is quadrant 1. This is quadrant 1. This is quadrant 1. Following my tangent, I have tan of pi over 6 plus tan of pi over 4 all over. The sign changes in the denominator. Right? This is plus, the denominator becomes minus tan of pi over 6, tan of pi over 4. Tan of pi over 6, that is 1 over root 3. Tan of pi over 4 is just 1. And these are the same numbers, 1 over root 3 times 1. So when I simplify, now it's a little bit hard for us to see, is this positive, is this negative? But you can tell this is positive and it's greater than 1, right? Because it's 1 plus some fraction. It doesn't matter if this is 1 or less than 1. This is 1 something. It's greater than 1 for sure. The denominator here, 1 over root 3. Root 3 is 1 point something. 1 over that is less than 1, right? So the denominator is some number that's smaller than 1 but positive. The numerator is also positive. So overall, it's positive. I know that's not necessarily important in terms of but it's a good way to just check to see, does my answer at least make sense in terms of the signs? You can't always check to be completely right or not. Obviously, you can plug this in a calculator, but I mean, that's lame. Okay, lastly, this last problem just wants you to rewrite it into a sum of angles. And you don't have to add or subtract the fractions at all, just rewrite it. But it's important to see that this is cosine, cosine, and then sine, sine, right? So that means that's a big indicator that this is a cosine sum or difference. So pi over 3, something, pi over 6. Now we got to see, remember that cosine, the sign does not match. So this was addition, now it's subtraction. So this turns out to be a difference of angles for cosine. My first term here is sine cosine for 12, sine cosine, and then I have cosine sine. So this must be a sine. Because for sine, the signs do match. This is subtraction. This is also a difference of angles. This is a little bit easier because they're all just tan, so this must be tangent. And since the numerator matches with my sine, it must be addition. Finally, cosine, cosine, sine, sine. That's going to indicate to me this is a cosine. And again, I need to take a look at what the sign in between is. This is addition. Cosine, it does not match, therefore it is subtraction. Okay, and if they told us we don't need to add any of these together, so I'm going to do more than this. Okay, hopefully this is helpful. Feel free to ask questions as you need.